Okay, which scalar and which vector? I have acceleration vector, charge scalar, kinetic energy scalar, wavelength scalar. To get uncertainty of x, we first can find the value from substituting L and T. It will be 45.8, and to find the uncertainty, it is a division, and here is a multiplication. Any variable to a power is a multiplication, so we should use the addition of percentage uncertainty. So we'll find the percent uncertainty in both L and T first, and after that we will add them as follows. Point 0.032 plus 0.032 or 2 times 0.032. This gives us, this is a percent uncertainty of x. We want here the apps uncertainty in x, so we will multiply this ratio by the value of x. It gives us 3.62. Okay, so if we choose the value to be 45.8, okay, we will not have an absolute 3.6, so we can round this for 46 and round this for 4. What is unit of power? And we know that power is energy over time, energy in joule, time in second, joule is force times distance over second, force in Newton is kilogram, meter second minus 2 times meter over second again. This gives us, okay, second in denominator will be second minus 1 in numerator, so it's B. We can resolve this 6 in horizontal and vertical direction, so it is 6 cosine 60 here, which is 3, cosine 60 is 0.5, and here it is 6 sine 60 or 6 cosine 30, those gives 5.8, 5.2 Newton. Okay, so it simplifies to 9 Newton, which is 6 plus 3, and 5.2 Newton vertically. Okay, for two perpendicular vectors, the resultant is square root of both magnitudes. This gives 10, or we can directly use the cosine rule which states that resultant of any two vectors with angle theta in between is magnitude of the first square and magnitude of the second square plus 2 AB cosine theta. Okay. Let us assume that, or it states that it is t. T is the time at which express train overtakes goods train. This time for the goods train means goods train cut 10t distance. Okay, so we want to find the time taken by express train to make this 10t distance. And as the question states that express train moves with uniform acceleration, we can use equation of motions, the one that contains s and t. Okay, we can use s equal u plus v divided by 2 times t, but we don't have v here, and we can use s equal ut. U is 0 because it was at rest. Okay, so s equal half at squared, and we certainly cannot use v squared equal u squared minus or positive 2as because we don't have again the final velocity v, so the only equation that we can use is equal ut plus half at squared or s equal half at squared. So you can remove t with the square, and it is 20 divided by a, which is 0.5, that gives us t, and this gives us 40. Area under BQ represent height. This is correct. Collision of ball with ground in elastic. This is also correct because we have the maximum velocity either downward. The downward velocity is the positive direction velocity, or in the negative velocity or upward. Here is upward and here is downward because we started the motion releasing the ball downward. This is the positive direction, and it bounces back in the negative direction v. So maximum either in positive or negative, either in down or upward directions, are decreasing. Okay, so it is inelastic. Gradient of rs is acceleration. Yes, gradient of any line in vt graph is the acceleration. max upward velocity of ball is reached at point B? No, it is reached at point R or this point or this point. So this is the answer. Okay, as we have air resistance negligible, the ball only falls under the gravity force, and for the vertical motion, it is only the acceleration due to gravity, which means it is motion under constant acceleration, and we can use equation of motion to find the time taken by the object to cut this vertical distance, which is also the time to cut the horizontal distance, because when we project some object to fall, okay, it will take the parabola path. So finding time if we have distance and we don't have anything else except initial and acceleration, initial velocity and acceleration, simply by using is equal ut plus half et squared. So it is half gt squared. Okay. We can rearrange for the time, and from this we can find that time is proportional to square root of y. So if we have for the second object the distance is 4y, okay, so we expect that this gives us a double of time, because this can be written as 2 square root of y. So as instead of square root of y, 2 square root of y, t will be 2t. Okay. Motion in horizontal direction with no air resistance means that there is no force applied. So initial horizontal velocity will be constant. So for either the first object or the second object, we have constant horizontal velocity of same value, and we have just the time doubled, so the horizontal distance will be doubled. So instead of x, it is 2x. In this part of the graph, we have a decreasing rate of increasing velocity, and this decreasing rate is because we have air resistance show up, so this will be C. just to remind you, as the first linear part, the fast increasing rate, we have only weight. In the decreasing rate of velocity with time, we have air resistance begin to show. In the first terminal velocity, we have air resistance and weight to be equal. Okay, if we continue by opening a parachute or increasing air resistance much more than the weight, we will have the graph to decrease until we reach again an equilibrium between air resistance and weight, which is the second terminal velocity. All collisions between two objects? No, friction must be excluded as an external force. Equal and opposite velocity doesn't restrict it to equal and opposite velocity. So it's C in an isolated system. And again, for D, it doesn't strict to same mass. Okay, so here we have momentum conserved. So momentum before is 9 times the mass m, okay, and for the 2m it was stationary, so 0. So this is the only momentum existed before collision. After, we have m times v1 plus 2m times v2. We can remove m from all of the equations, so we have 9 equal v1 plus 2v2. Okay, we have also a head-on motion before, and we have elastic collision. This means that relative velocity of approaching equal to relative velocity of separating. So we have u1 minus u2, okay, equal v2 minus v1. Okay. You can return back to your syllabus and try to follow the mathematical derivation for this relation, and please leave a comment if you don't find it. Here is u2 is 0 because it is initial velocity of the object of 2m mass, so we have only 9 equal to, okay, we can name it as 1, and this is s2, and we can rearrange 2 to be v1 equal 9 minus v2, and then substitute 2 and 1. So we have 9 equals 9 minus v2. So we have it as Oh, sorry, there is a minus here. If we send this to the other side, we must divide by minus. Let us rearrange in a much easier way as V1 plus here, and here is V2. Then when we substitute N1, we have V1 plus 18 plus 2V1. So we have 3V1 equal to minus 9. So V1 equal minus 3, and we can from equation 1 here, or from equation 2, find that V2 equal 6. Resultant force is delta B by delta T. So it is a gradient here, 5,000 divided by 10, 500. So initial upward force minus the weight should give the resultant force on the rocket, and resultant force is M times A. F of the initial force will remain as the same, and I will move this to the other side as positive W. Okay. We can choose A as M is equal to weight over G.